Hey guys, in this video I'm going to be doing a tutorial on the character controller I've been using in my 3D world style Mario game. If you've seen that on my channel, I haven't uploaded any videos of it recently as I realized my Mario Kart game was more popular, so I just decided to focus on that. And I'm going to be showing you how I created that character controller. And speaking of Mario Kart, I'm going to be uploading that video next week. I decided to do this one first, as it was, first of all, it was a request by someone in my YouTube channel and a few other people watching those videos, which I haven't uploaded recently. And second of all, before school starts, I thought this video would be easier to get over with, while school's like not start hasn't started yet. So let's get on with this. I'm gonna be showing you how I approach this in my actual game. I have set up a basic scene here with a few assets. Um, Here's the player over here, and let me first explain, or first let me show you how it actually works. So the WASD keys help make you move around, and there's an animation playing. The goombas are static. I didn't add any code to make them chase you or anything. I just added them here for demonstration purposes, for when Mario can like jump on them and all that. But I didn't. You can add the code for the goombas later. If I'll leave this project in the description, so you guys can play around with it, add your own stuff, or turn it into another game or whatever. So yeah, so you can move around, you can jump, simple animation for that. You can also crouch and move around while holding a specific key, and you can also ground pound right over here. So I can just jump up here, then do a ground pound. So I can jump on these guys as well. That's why I have them here. And you can also ground pound them as well. So they disappear, so they're gone. And there's also wall jumping, which is why I have these two stretched out cubes over here. I didn't add any effects like the dust and everything. So, yeah. And let's get right into the tutorial then. Or the code. So I'm gonna walk you guys through each of the functions. Just like my other tutorials, I don't show myself writing the code. I just show the code itself. So yep, let's get right into it. Here I have several variables over here. I'll explain all of them when we come to it. But first, I'm going to be explaining this. I'm going to be explaining this move function right here, which is what basically controls his movements. And this is a very basic implementation of a character controller. So let's start off right here. So what we have here, we're declaring a vector 3 called real velocity, just in case we might need this velocity for something else. And we're setting it to the player's velocity, the rigid body velocity, and we're calling it right before we set it. So if we have any condition that we want to meet in some other function of our player controller, which you might implement in the future, if you're on the player's real velocity, you always want to check it before you set it, because if you set it and then you check it, it'll always return what you set it to. So this is what the real velocity of the rigid body is. So aside from that, we don't really need that right now. But yeah, I can leave it there. I'll just leave it there. Next, we have a vector 3 called an input vector. And this is what we're going to be feeding input to. And we're going to use this as a base for our velocity directions. So here we have float x is equal to input.getAxis horizontal. So if you didn't already know, every Unity project by default has the horizontal and vertical inputs set to the WASD keys or the arrow keys. So technically, I could be controlling that player controller with the arrow keys as well. I was just using WASD keys as it's easier for me. And same thing with the vertical. That's just the up and down keys or the W and S keys. And this is like the A and D keys. So A and D, or left and right arrow. So I'm not gonna put the comment for this one because it's pretty self-explanatory. Then we have more vector 3s, and this is for the camera rotation or camera relative movements. If you didn't already well, I didn't actually show you guys, so let me show you real quick before I explain. If you use your mouse, so oops, and yeah, you can also shoot fireballs. I forgot to explain that. I'll cover that in a bit. I didn't add any animation for that. Obviously, you can add the animation for it, but anyways, what I was saying was that you can plug in your mouse. I'm just gonna be using my trackpad for now. You can use your mouse and you can rotate the camera. But notice how if I press backwards, if I press the S key, he moves towards the camera. If I press the W or forward, he moves away from the camera. And left and right is relative to the camera. If I rotate the camera this way, well, his left and right goes accordingly to the camera. And that's really important if you want to have a really good if you want the user of the game or the player of the game to have a really good experience, because no one's gonna remember like if the camera's here, the up and down is that's up, that's down. No one's gonna remember like all these different directions. So you want to have camera relative inputs. So that's what those two vector threes in the script are used for. So one is called xMove, and that's gonna be camera.main.transform.right times x, and x is our input for the horizontal axis. And we're multiplying, and transform.right is just a relative direction to the right, and transform.right, if you don't get the left direction, you just do negative transform.right. And since x can range between -1 and 1, that pretty much has the left and right thing covered. So that's the x move. Same thing for the y move, but that's transform.forward times y. And if you're on backwards, transform.back. There's no such thing as a transform.back in the code, but you just multiply transform.forward by a negative value, and y can be a negative value as well. So forwards and backwards is covered right here. So now what we're doing in our input vector is that we're adding these two and plugging it into our input vector. So input vector equals x move plus y move. So we just create a single movement vector from the inputs. Now we have a variable called move speed, which is in the inspector as well, so you can see it. We just multiply our input vector by move speed, so we can set how fast Mario can run. And now we also do input vector dot y is equal to rigid body dot velocity dot y, because we don't want to affect the y velocity or the gravity. We want to make sure we leave that alone. Then we set the velocity to the input vector we just created. And I have an if condition here. So if we're not currently ground pounding or we're not wall jumping, then you can control it. Because if you're ground pounding or wall jumping, I don't think moving around is possible while you're doing that. So here's an if condition for that. Now, to make the player actually face the direction he's moving in, I have a long if statement here. But then I have a rotation, which is equal to I have a rotation, which is a vector 3, which I've declared here. I have a global because I need it in another function, I think. Yeah, I need that in another function, so I made it global. But I set rotation to the input vector .x and input vector .z, right? I want to extract those components. We don't care about his y rotation, or well, we do, but you'll see in a minute why we don't need the y component of this. So now we're setting the rotation to this vector, and we're using quaternion.look rotation. That is why we don't want anything on the y-axis, because we don't want the player to rotate, well, up and down. We don't want him to look up. We don't want him to look down. We just want him to look left, right, backwards, forwards, like that, right? And look rotation is basically you have this vector, and you're trying to look. You're setting the rotation in a way that the player looks towards that vector. So yeah. So I hope that was clear to you guys. And in this if condition, we say that if the get axis raw of the horizontal axis is not 0, and basically get axis raw is basically a value that is that has 3 different values: -1, 0, and 1. However, regular axis over here has values in between -1, 0, and 1. So it can have different decimal point values, but raw is just 3 values based on what you press. And this is useful if you don't really need to approximate but you need a certain value to have an indication of what the player is pressing. For example, if the player's um uh well the player's input on the horizontal axis is not 0, and the player's input on the vertical axis is not 0, and sorry, not and, I meant or, and then you put a parenthesis around this big statement, and you put and you're not wall jumping, then you set the rotation. Because if we're wall jumping, well, we're using this rotation vector for something else in that function, and we don't want to mess with that either, so we wrap it around this if statement. So the player won't rotate if you're pressing something. If you're not pressing something. So the player won't rotate if you're not pressing anything, and you're not wall jumping. So that's when the player will rotate. So okay, sorry, I think I just confused you guys. The player will rotate when there is some input and you're not wall jumping. Otherwise, the player won't rotate at all. Will just stay the way he is. Okay. So now we have these variables x and y over here, so we can just use them. So if x does not equal to 0 or y does not equal to 0, we just set the running animation to true, because if x and y are not 0, then we know the player is supposed to be moving. And anim is actually the animator controller. I have declared right over here, and it's private, and we can just do get component and all that. But yeah, so animator controller, and we have a boolean which controls the animations, and one of them is run. We have several booleans in the animator controller, but one of them is run. So we just set the animations over here. Then if we are pressing the V key and we're grounded, we're not ground pounding and we're not wall jumping, then we have this boolean, a global variable called crouching, to true. We set that to true. Then we reduce the velocity, and this overrides the previous velocity assignment that we did over here, because this code is run after this code. So whatever happened here, if we do the same thing again over here with different values, this gets overridden. So we set our velocity to input vector, but this time we divide by 3 because Mario doesn't crouch as fast, doesn't walk and crouch as fast as he runs. So we slow him down. We also have a boolean called crouch in the animator controller. We set that to true. And now I have something interesting here. So I have two different colliders on Mario. One is a sphere collider and one is a capsule collider. Well, the sphere collider, if I check out the player object, this is the capsule collider, which is up to height with Mario. He's in a weird default animation right now, but it'll change when we get back into the game. But this capsule collider is the same height as Mario, starting from the bottom where his feet are. Now I have a sphere collider, also starting from the bottom where his feet are, but it only goes up to this high. And the purpose of crouching is so you can get to tight areas, and so we want a smaller collider for that, right? So I have a sphere collider and a capsule collider. If you're crouching, I disable or enable either one, so you can, smaller areas, so you can fit in smaller areas. So that's pretty much the move function, and all that does is rotate and move the player, and there's also crouching in there. Let's move on to the jump. And let me mention how you check if the player is grounded. So we have several on collision, on trigger, enter functions and all that. So one of them is on collision stay. This function runs every frame. As you can see, is on collision stay, not enter. So this function runs every frame, and what it checks for is, is the collision object that you're currently touching, does it have a y normal which is greater than 0.5, and you're not pressing the space key. So this may be new to you guys, but collision context 0 index dot normal dot y, this basically returns the normal of what you're touching, the normal. And normals is basically the steepness or the direction the surface is oriented in. Kind of like if this y value was less than 0.5, it would be a very steep surface. It would be like a steep diagonal surface, right? But if it's greater than 0.5, then the normal dot y would be like, or the surface itself would be like a very mild, diagonal surface, and 0 would be a completely flat surface. And this applies to z and x values as well. And we'll see these later on when we're wall jumping. But keep this in mind, if you want to be grounded, you can't be grounded on a really diagonal steep surface, because like we're using this for jumping, and jumping is, well, I don't think that's really applicable on really steep surfaces where Mario will generally just slide down. So yeah, and also you can only be grounded if you're not pressing the space key, because if you press the space key, you're jumping, so then you're not grounded. And also, when you're grounded, you can't be wall jumping, so your wall jump gets cancelled because this boolean gets cancelled. And we also set the boolean in the animator to false as well, and we set this to true. Now on collision exit, so if you're not crouching and you exit the ground, or you stop touching the wall, the ground, then grounded is false if you stop touching the ground, okay? And obviously you can have specific tags for what what surfaces you can actually be grounded on. For example, maybe you don't want to be grounded on some rocks, or maybe there's some area of the level you cannot jump on, then you would separate this by tags. I'm not using tags because a character controller, you can practically jump on anything, as long as the steepness and everything is fine. So yeah. Now I also have an on collision enter, but that's for the Goomba, so we don't have to worry about that. And now let's move on to the actual jump function. So in the jump function, I have if jump bool and you're grounded, and jump bool is like a boolean which is used to check if you're supposed to jump or not, and you're not ground pounding, and you're not crouching, then you can jump. And let me show you how I got this jump bool function. You'll notice there's two update functions. There's fixed update over here, and there's regular update. Fixed update is used for a lot of physics, because fixed update is physics based, while update is run on 60 times a second. So update is based on just time, and this is based on physics. So if you want to have velocity and everything going on, it would be better if it was in fixed update. It would be more smoother. And if you're in update, well, I found out that update registers inputs way better than physics or fixed update. So I have most of my inputs here, and then I have my actual functions, the functions I use physics, in the fixed update. So how I got the jump bool. So if I press down but not hold, just press down on the key and let go, or whatever. Just get key down means you press it once. If I press the space key, then jump bool is true. Okay. Now that's basically how I got the variable jump bool, and jump bool is a global variable declared here. Then what we do is we go back into a jump function. If all these conditions are met, then we add a force, upwards force, vector theta up. Then we multiply by jump force, which is a public floating point value, multiply by time the delta time to, well, even it out on different frame rates depending on your monitor. And then we add it as a force mode, as an impulse force, okay? Then as soon as we press it, we're not grounded anymore. We don't want to jump 60 times a second. So we set jump bool to false, and grounded is also false because we just jumped. And the jump boolean in our animator is set to true because we're jumping. And if either one of these conditions are not met, then jump bool is false because we're not jumping. So yeah, it can't be the boolean can't be true because we're not jumping. Okay, that basically covers the jump function. Now let's look at ground pounding. So this ground pound function is called in the update function, as you can see, if you're not grounded, so if you're not touching the ground, if we're not ground pounding already, and we press the V key, but we only press it once, then we start the ground pound function. So get key down registers only once, so this function is only called once when you press the V key, but then it's not called like while you're holding the V key, okay? So let's go into the function. So what we're doing, first we have a raycast hit. So it's basically, we're just declaring an object which can store the information of a raycast hitting. So, and I don't know what I wrote here, but it stores information about what the raycast that we shoot later on actually hit. And I guess it can act as a detector as well because you're using it in the actual if statement or when you throw it. So, anyways, then we also have a ray, and we're just calling it down ray, and we shoot a raycast downwards, as you can see by negative vector 3 to up, to see how far we are from the ground, because we don't want to do a ground pound, if we're literally like an inch from the ground, right? That makes no sense. So basically, we shoot the ray downwards, and we store the information inside hit. So, and yeah, as you can see by this comment, then obviously grounded should be false if it hits something. We're not actually supposed to be grounded when we're doing a ground pound. And we set ground pound to true as well. Let's see. This is all code that I've used in my actual game. Obviously I've modified it a little bit, so I might have to like review it. But it's not like I don't understand it. There's a purpose for everything over here. This is code that I was experimenting with earlier in this project, which is not really necessary in this project, so I just commented out. But I'll just leave it in there. Actually, no, it's okay. I'm just gonna comment it out. Yeah. So ground pound is true. Then we set the rigid body drag. If it is anything else, we set it to 0 because we don't want to slow down our ground pound. Then we have our boolean, which is true. Then this is the boolean for the animator ground pound. That's another boolean inside the animator. And we also set jump to false because if we're jumping and then we press the ground pound key, then we should stop our jump animation and then go immediately with the ground pound animation. Then first we freeze the velocity. If you've seen in Mario games, when Mario does the ground pound, he stops in midair for a second, does a spin, and then pounds down, right? So first we freeze the velocity. We also stop using the gravity. We just try to limit all the external forces as we can. So he's frozen in midair. So next what we do is we wait for half a second, and you'll notice it's an enumerator because we have this yield return new wait for seconds in there. So yeah, we wait for half a second. Then once he's done freezing in midair or whatever, then we add a really fast velocity downwards, which is -30 or -30 on the y-axis, but nothing on the x and z-axis. And we also set the mass to 100. And this is really important because say if you're ground pounding on a Goomba, when you ground pound on the Goomba, you don't want to be moving around or sliding around in different places, right? If you bounce off of the Goomba. So if you set the mass to 100, this prevents him moving around randomly while he's ground pounding if he bumps into anything. And this is just, I guess it's an inefficient way to pause a function. But basically, while we're not grounded, we're basically just waiting. We're not continuing on with the rest of this code. We're just waiting, and every time we just keep waiting 0.001 seconds. This is some quick way I thought of to pause a function at the time. So yeah, and once we move on from this code, Mario is grounded because otherwise you'll be stuck in this code if Mario is not grounded. So when we get over here, Mario is grounded. So then we set a shake animation, or we set this trigger in the camera's animation. Sorry, I confused you guys. The camera also has an animator on it. and it has a trigger called shake. So we set that trigger, and it kind of has a small effect animation for the shake. Then we wait 0.1 seconds. Then we obviously reset everything that we just mess around with. However, we first we set use gravity to true. Then we also set rigid body that is kinematic to true, because we still have to wait for Mario to get up, and we don't want him to slide around while he's getting up. So we set rigid body that is kinematic to true, so he stays where he is. Then we wait another 0.4 seconds. Then we reset all the other modifications, such as ground pound to be false. We reset the boolean. We set it to false in the animator. We set rigid body that is kinematic to false, and we reset the mass. And obviously the mass of the player was let me just check the rigid body just to make sure. It was 5 in the first place, so we have to set it to 5 right here. And yeah, that's pretty much it. That was just code that I was experimenting with. I'll explain the wall jump function right after this. But let me explain the Goomba stomping first of all before I get into the wall jump. So I have two ways to tell how you collided with the Goomba. First of all is a collision. Now, collision is just when you bump into a Goomba, and to make sure that you bumped into the Goomba, but you didn't bump into the Goomba from above, because that would be killing the Goomba, we will make sure rigid body dot velocity dot y is greater than -1. Because if you're moving downwards from the air, then the rigid body dot velocity dot y would be less than -1, right? It would be like some -10, 15, or whatever, right? So we just have a direction vector. I just like set it to the difference of the two positions that normalize. Then we just add an impulse force in that direction, so we just get pushed back by the Goomba real quick, and that's pretty much it. Now this is the more important part, the on trigger enter. This is we kind of enter a special collider placed on top of the Goomba, which detects for collisions that are specific to killing that Goomba. So let me show you what that trigger is. So if I focus on one of these Goombas, it has two colliders on it. It has a capsule collider, which is it for just the physical collisions itself, and also a box collider, which is set to is trigger. This is very important. Then, if you look at it, it's placed right on top of the Goomba. Okay, so if you enter this trigger, that means that's technically telling Unity that you are trying to kill the Goomba. But to make sure it was not accidental, we also check to see if the rigid body of the y velocity is less than 0, or it could be -1. Doesn't matter. It's a very small difference. Then we have a special script on the Goomba, which is to die, for the Goomba to die, to kill itself or whatever, which is right here. It's just a basic script with a simple function in it. I'm not going to explain this. You guys can experiment and check it out on your own because it's not related to the player. But yeah, so we start this function, and we also add a jump force upwards, because when the player jumps on a Goomba, you notice how you've probably noticed how he like comes back in the air, like he just bounced off of the Goomba. So we have another jump after you jump on the Goomba or stomp on the Goomba, and this all applies for ground pounding as well, except for this line, because when you're ground pounding, you're not going to be jumping up while you're ground pounding, because all the velocity that we're setting over there in that function is overriding when this is being called. So all the velocity that we're setting in the ground pound function is overriding this line of code, so we don't have to worry about it when he's ground pounding. And that's how you stomp on a Goomba. I can show you if you didn't see it already in the beginning. You can just ground pound. Whoa, okay, that was weird. That was my computer with late inputs and all that. As you can see, Yep, and you can add special dust effects for Goomba disappearing as well. I didn't do any of that. But yeah, that covers the stomping on the Goomba part. Now finally we have wall jumping. Well, not finally, but finally as in the main stuff. So first, let me actually you have already seen what wall jumping does, so I'm not going to go back. First, we declare a raycast hit and a ray, and I have a transform called wall ray detector, and let me show you what that is. So that's over here. If you look into the player's collider, his collider's over here, and here's the wall ray detector. I know the collider looks like it's out of place. It's just because Mario is in like a weird state or in a weird animation frame right now. But if he was in an idle animation, he would be right perfectly along the center of the collider. So according to the collider, I have this transform which is placed right around his head, right? Because this is what the raycast is gonna be shot from right here, from this transform in along the blue axis over here, to detect if he's actually face to face with the wall. Okay, we don't want to wall jump if his legs are touching the wall, but his face is above the wall, because he's supposed to be grabbing onto the wall to try to drag or wall jump, right? So he would be grabbing nothing if only his legs were touching the wall. So this has to be placed around his head area. So we shoot a raycast from that position, and we shoot it in the forward direction. And we also have a raycast hit over here. And to see if the player is off the ground, we have another raycast hit called hit ground, and we also have a ray called down ray. And if we shoot it downwards, and we shoot a raycast downwards, and this tells Unity if the down ray hits something and transfer the result into hit down. So we transfer the result of this raycast hitting something below into hit down. Okay. Now we have a boolean over here. So first of all, we have off ground is equal to false. But over here, off ground is equal to the hit down distance if it is greater than 0.2. So if the hit down that distance, so if the raycast hits something at a distance greater than 0.2 from the bottom of the player, then off ground is true. Otherwise, off ground is false. That's why we set off ground is equal to false right there. Okay. So now this is a really important part of the function. So if we hit a wall at a distance of 0.7 or less, and the y normal of the wall is less than 0.05. So the wall is very steep. If it's completely steep, like perfectly upwards, or just a tiny bit slanted, then it's okay to wall jump off of that. And if you're also not touching the ground, and your rigid body velocity is less than or equal to 0. This is because if you're jumping up and you just happen to be standing right next to a wall, I don't think you want to be dragging upwards. You only want to be dragging if you're moving downwards, right? So if your y velocity is less than or equal to 0, and if all these conditions are met, this code is executed. So let's start off. So rigid body drag is equal to 5. So initially the rigid body drag is 0, but since he's sliding down a wall, he's using his hand to slow down the falling process, right? So we set the drag to 5. We also set the boolean wall jump bool to true, and we set wall jump, the boolean inside the animator, to true. Yes, he has a specific animation for wall jumping and like sliding around, so we set that to true. And we also set jump to false, because if he's jumping in midair and he latches onto a wall, then we don't want him to have the jumping animation anymore. We just want him to have that sliding wall jump animation. Then we have an if statement right over here. So if he is not grounded and the raycast hits the wall, is still hitting the wall at a distance of 0.7 or less, and the hit normal is, and the wall is still steep enough. I don't know why it's different here than it is over here. I guess I can just change it to that, but I'll just leave it for now. but since everything works, I don't want to mess anything up by accident. And the wall is steep enough, and you press the space key, and this is a boolean I've declared again. And as I mentioned before, jumping and other inputs are registered better in update rather than fixed update. But this wall jump function is in fixed update. So I have to do this whole boolean thing with in the update function as well, so I can transfer any key inputs into fixed update. So if you press the space key once, space is true. If you stop pressing it, space is false. Okay, pretty simple. So back in the wall jump function, and you're pressing the space, and you press the space key once. We also set space to false over here, because what if the player is still holding the space key, but we don't want to keep telling Unity that space is true. We don't want to keep saying that the player is holding down the space key. So as soon as the player touches the wall during the wall jumping process, space is false. Okay. Otherwise, what would happen if we didn't set space here was that the player could be automatic jumping off the walls if the space key is held. As soon as the player touches one wall, he would go to the other wall, and like that. So we want to make it more intuitive for the player and how it's actually supposed to be. So we set space to false. Also, we set wall jump bool to true because he is wall jumping. Then we modify the player's rotation by in a vector 3 form. So transform that Euler angles. We don't modify anything on this and or anything here. But we modify the y-axis, and we're adding on to the existing Euler angles of the player. So we just add 180. And if you think of a circle, 180 is directly on the opposite of the circle, and 360 is all the way around the circle. So 180 would be the opposite direction of where the player is facing right now. So if you're jumping off of a wall and you jump off of it, the player should be facing to the opposite side of the wall. So that's why we add 180 to the player's Y rotation over here. And I even commented here, face the opposite direction of the wall. Then we add the rigid body velocity. We set it to 0 first of all, and we change on the next line so we can stabilize the jump. Because say if the player's velocity is really high and then he wall jumps, we don't want any pre-existing velocity to affect our wall jump. So we reset it and then we set it over here. So what we have a raycast hit over here, right? That gets the normal, right? So we can access the normal component and get the x and z component out of it, which tells us the direction of the surface we just bounced off of. And I just found that these values work the best, 8 and 7. You can do 8 and 8 or whatever. It doesn't really make a difference. I just experimented and found these work nice. And we also add 20 to our y velocity because we're jumping upwards, of course. And this happens once. And since it happens once, we're not adding rigid body velocity. We're not adding 20 to it constantly. And because, space, we only press the space key once, and that's the jump input, right? So this velocity is added once and is done. So all this code is done once and it's done. Then we set wall jump to false, which is a sliding animation off of the wall. And we actually set the jump animation to true because we're jumping off of the wall, right? And if none of this happened, then we just set wall jump to false, and we set the drag to false, 0 as well. And when we set the wall jump boolean in the animator to false, this immediately, the way I set up the animator, it just immediately takes us to the idle animation because that's the only place the current state can go to. So you're just staying idle at the moment while you're falling down and whatever. So if these conditions aren't true, then there's no wall jump, okay? So that gives us our player controller. That's pretty much the player controller. And now I have an extra thing, which is throwing fireballs, because it took a lot of experimenting for me to get fireballs working correctly. So I thought I might as well just show it right now before anyone starts wasting their time on it. But this is basically what we have accomplished with all those functions. And yeah. So now let's go into the shoot fireball function, which is right over here. So if you press the left key or the left mouse button, then we have an animation. I didn't set the animation, or I didn't initialize the animation in the animator controller, so this currently does nothing. And we also set jump to false, so you can throw animations in mid-air. So while you're in the air and you're jumping, you can also throw fireballs and play that animation while you're in the air. So we also set jump animation to false. Then we wait for 0.1 seconds before we instantiate a fireball. So I have a fireball object, which I have put right here as a variable, and we instantiate that. And we also have a transform, which is the fireball spawn location. This is where the fireballs will be spawning. We don't want them to spawn directly inside the player or like some weird location, or where the player's feet are or something. We want a dedicated location to where to spawn them. So we just spawn them here, and the rotation doesn't matter. So I just put fireball, that transform, that rotation doesn't matter. All that matters is the velocity of the fireball. So first we enable the script that's attached to the fireball, and if you actually look at the fireball right here, it's just a sphere with a shader I have added and some particle effects. So if you actually move the fireball, there's some flame effects going on behind it, but all it is right now is a sphere with a particle system and a shader on it for the material color, which is this over here. It's a shader graph I made, and I'm using lightweight render pipeline if I didn't mention that, which is why shader graph is readily available. I mean, you can't have it in the standard pipeline. It's actually called universal render pipeline, by the way. I'm just used to that old term because that's when I started using Unity. Back when it was called that. I think it was called that a year ago or something. Anyways, so that's just a random game object in the scene. You can't really see it from here, so it doesn't matter. But then when we instantiate a fireball, we have to enable its script so it can actually work. Now we set the clone that we just instantiated, its velocity, to vector 3 that I have declared in our actual player controller, which is right over here. So it's a public vector 3, and we set the velocity of the fireball to that, as you can see, and transform direction. It basically gets the local velocity of the player and adds the specified vector 3 to it, because if the player is facing, for example, this way, for example, east or something, then the forwards would also be east, and the left and right would be, well, south, north. You know what I mean, right? So we want the local direction, not the global vector 3. Okay, so that's the fireball. So if you actually look here in our player script, this is the fireball's initial velocity, and I also have a fireball script which it controls what happens when a fireball bounces into things. Yeah. And one more thing which is important to keep in mind before we actually go into the fireball script is the fireball has its own layer, and so does the player. This is because we can separate the collisions between the fireball and the player, so the fireball doesn't push or bounce off of the player, and they don't bump into each other as well, which I've actually modified in the project settings and physics right here. Right over here, fireballs do not collide with player, and fireballs do not collide with themselves as well. So yeah, so let's go into the fireball script, and this is the last thing I'm going to be covering in this tutorial. So yeah, first of all, we have a vector 3 velocity. Well, since we shot a fireball, actually this vector 3 is not in use at the moment we spawn the fireball, but in the start of when this fireball is instantiated, we set the velocity to the rigid body's actual velocity right now. Okay, so we just get the rigid body, but here, since the gravity acting on the player is way less than the gravity acting on the fireball, because the fireballs are really bouncy and they fall down really fast and all that, we're adding our own custom gravity to it. It's just a downwards acceleration that we're adding to it. I figured out these values by experimenting a little bit, but yeah. So if the y velocity of the fireball is less than what is actually declared as the initial y velocity of when this fireball was instantiated. Then we set our y velocity, or we set our velocity on the fireball to that vector 3 that we that was initially declared. Because if you don't have this line of code, the fireball will be able to just create arcs, and because as you know, when you release the object, it moves faster and faster downwards until it reaches a certain value. But we don't want it to move faster and faster downwards. We want it to move at a constant rate. It should be straight down. It should create a line on where it's going. It shouldn't like fall down slowly and then gradually speed up or anything. That's not how fireballs in the 3D Mario game actually work. So we have to have this piece of code over here. Now this is the important part. This is on the on-collision engine. So if you collided with a surface that's reasonably flat, as you can see by the collision contact normals, and it's not it's not too steep anyway as well, right? If it's in between a range, right, the normal, a specific range. I can't exactly remember what these would look like in Unity, because this is from the actual Mario game I created. So at the time I probably knew, but I probably forgot now. But if the steepness of the surface it collided with is within a certain range, then we basically similar to bounce. A bounce is when you just say if you're going down and we hit the surface, you want to go up. So we don't modify the x velocity or the z velocity. We just multiply the y velocity by a negative. Because if you're going down, the y velocity is negative. But if you add a negative to already negative velocity, it becomes positive. So it starts going up. So that's a bounce. And then the gravity takes care of the coming back down part. So we don't have to worry about anything here. And we also have a reflect if it bumps into walls. So if you're colliding with a wall which is reasonably straight up, not too if it's not, I mean, you can't bounce off of a diagonal wall, so we want to make sure it's not too diagonal anyways. And we just make sure by checking the z and x normal of its collision contacts. So we have an vector 3 called old vel, which is equal to the current velocity. Then we normalize it, and then we also have to multiply it by the specific number that I came up with, which works fine. And then we also have a vector 3 called new vel, which is the reflected version of old vel, and the second parameter is the collision normal that we collided with. So if the surface so pretend, actually instead of pretending, let me just show you. So each surface has its own collision normal when it collides with something else, and it's stored in collision contacts and all that. So if I throw a fireball in this angle towards that wall, which is pretty straight, as you can see, it bounces off all around off of different surfaces. And it's kind of like a reflection. Like if you follow light rays on a mirror, they'll go in one direction and they'll bounce out in another direction. So that's what the vector 3 reflect does. It's a pretty convenient function in this case. And then we just we set the new velocity, or we set the fireball's current velocity to the new velocity is x and new velocity is z, but we don't want to modify anything in the y. We just want to leave that as is. Then what we do is, I don't even know why I have this line of code here. It probably doesn't even do anything. So I'm just gonna leave it in there, but it probably doesn't do anything because this line does not do anything. I can confirm because it's just setting a value to what it is already, so it doesn't do anything. Now, obviously I also have a destroy function. If I go into the actual player script where we actually we don't even use this destroy function, but basically what you want to do is after you shoot a fireball, you wait like a few seconds or maybe like 10 seconds or something, then you would call this function to destroy the fireball. I'm not going to go in depth of what it is. You guys can check it out yourselves, but you just destroy the fireball, and yeah, that's pretty much it. That's pretty much this whole character controller tutorial. I know it was a long one, but I went in detail in everything. Let me know if I missed anything, because like, I just created this project. I didn't spend too much time on it. I just did whatever I could, what I thought was the most important. So let me know if you have any more questions in the comment section, and let me know if it helped you or not. And yeah, if you found this helpful, good. Like the video then. And please consider subscribing. That would be pretty awesome. And thanks. I'll also have a link for this project in the description. So yep. So that's pretty good. And my next video about the Mario Kart Progress number 9 will be coming out next week. It's gonna be a different type of video. I'm gonna be doing a feature video. So basically, half of the video shows the different features I added, and the other half is just gameplay. If you want to skip right to the gameplay, but more on that next week when I upload the video. And thanks for watching, guys. See you in another video. See you guys. Bye.